Previously, we supported the ability to grab valid transactions from the pool, and now to also create a reward transaction within the transaction class. Last up, we need to make sure that the transaction pool can be cleared. So let's describe a new block of tests for a clear function in the transaction pool.test.js file. So after this valid transactions block, we're going to have a new block for a clear function. Cool. And within here, we'll have an it test that says it clears the transactions. So it clears the transactions. Very nice. The first line that we'll call is a new function called transaction_pool.clear. And as far as an assertion, well, we should expect that the actual value of the transaction pool.transaction map is now going to be blank, which we can assert that it is a blank object, or rather that it has the same properties as a blank object. Okay, so that actually completes the test for a new clear method. Feel free to implement the code yourself. Otherwise, head to the command line, fire npm run test, and you'll find that the error that is going is that transaction pool.clear is not a function. So let's go ahead and implement transaction pool.clear. So right before set transaction, let's add this clear method, and then this is going to set this.transaction map to an empty object. Now, as we save this, we should find that in the test runner that this will actually complete the clear method, and we have a fully green test suite. Cool, that completes the clear method, but this might just be a little too powerful when a peer accepts a blockchain full of new transactions. If it blindly clears a transaction pool, it might wipe away certain transactions that are in its local pool that haven't been included within the blockchain that's been received just yet. Therefore, we're going to implement an almost similar clearing functionality that will run based on the blockchain. But the difference is that it's going to check whether certain transactions have been recorded in the blockchain and then wipe away those transactions if they exist within their transaction pool. This functionality is going to be called clear blockchain transactions. So again, we're going to return to the transaction pool.test.js file. And we're going to describe a new method called clear blockchain transactions. And again, this is a more safe version of the clear method that will only clear the transactions in the transaction pool if they're included in a new accepted blockchain. And then our one test in this check is that it clears the pool, so the pool of any existing blockchain transactions. All right, nice. And first up, we need a blockchain to record transactions in the first place. And I don't believe we have a blockchain class in here yet. So let's require that at the top. So a constant of blockchain is the result of requiring the blockchain file. And this is located one directory back at the blockchain directory. So now we have the blockchain class. And then within the test, this is the only one that needs a blockchain. So let's make a local blockchain constant for that test. And now we'll take an approach very similar to our valid transactions method above. We're going to run a loop that creates a transaction and sets it in the pool every time. But only in half of the loops are we going to add that transaction to a block in this local blockchain. The other half of the time, we'll keep the transaction in an expected transaction map variable. So that way we can see whether or not after calling clear blockchain transactions, all those blockchain transactions get removed from the transaction map. So the actual value of the transaction pool.transaction map should equal our expected transaction map overall. So let's run this loop 6 times. We're going to make an I incrementing variable that goes up to 6 and then I plus plus. And in each iteration of the loop, we're going to make a new transaction with a new wallet instance. So let's make a new wallet every time, and then this allows us to call create transaction. Then we can pass in a recipient and an amount. The recipient can be anyone. How about foo? And then the amount as long as it's small enough. So 20 works just fine. And then every time, let's set the transaction within the local transaction pool for this test. So let's call transaction pool.set transaction. But for half of the loops, we're going to add this block to the blockchain, or rather a block consisting of this transaction to the blockchain. And in the other half, we're going to set this transaction within the expected transaction map. So if I%2 is equal to 0, so for every even iteration of this loop, we're going to add this block to the blockchain. And this is going to be a data field that consists of an array that contains this transaction. So when we include a list of transaction in the blockchain, it comes in an array. So therefore we add in an array data field that consists of the transaction to the local blockchain. Otherwise, we have this expected transaction map. So create the expected transaction map and set it to an object. And this allows us to go to the else case where we set the expected transaction map. So this should be called map at the transaction.id to that very transaction. So to review, we're making a local blockchain, an expected transaction map. We're running a loop 6 times, and every time we're making a unique transaction, as well as setting it in the pool. Half of those times, we're adding a block that consists of a data array with that transaction to the local blockchain. Otherwise, we're saying that the expected transaction map should contain this transaction at the transaction.id. All right, that completes the looping. Now we should call transaction pool.clear blockchain transactions. And as the input to this, let's provide an object that contains a chain array. And the chain array is the local blockchain.chain. Nice. And now after calling clear blockchain transactions, the only transactions that should remain in the pool, even though we've set all the transactions within the pool itself, should be the transactions in the expected transaction map. Therefore, if we expect that the actual value of the transaction pool.transaction map, that this should be equal to our actual value, or rather our expected value of the expected transaction map. All right, nice. So once you save this, if you have a test still running in the background with npm run test, you're going to find that there is indeed a new failing test within the command line. So let's get this to green. In the transaction pool.js file, we're going to make the new method of clear blockchain transactions. And this takes in an object with a chain array. As we save this in the command line, now the actual method is going to be defined, but we still have to implement the logic. So let's go. Yep, definitely the logic is off. It's expecting all of these transactions to be removed from the expected transaction map. That's why there's all this red, but this gray object is okay. We're actually expecting those values to exist, but anything in red we should have removed by calling this clear blockchain transactions method. Okay, so to go about doing this, we're going to go through the entire chain array and look at each block's transactions. So we're going to iterate through the array by starting at 1, so that way we skip the genesis block. We're going to go up to the chain's length and then increment I every time. And in every iteration, the I variable represents the block in the chain. So the constant of block equals chain of I. This now allows us to go through every transaction in the block. Let's do that with the for let of syntax, which allows us to create a variable automatically for an array of data within a for loop. So it's a nice convenient syntax. And then if the transaction map local to here contains a value at that transaction ID, we'll make sure to delete that reference. So if that transaction map contains a value at the transaction.id, we want to make sure to get rid of that reference. And to get rid of that reference, JavaScript gives us the delete keyword for objects. And we call delete this.transaction map. And we're going to pass in the value at the transaction.id. So overall, make sure to go through every transaction of the block's data. If this.transaction map has .transaction.id, then go ahead and delete that reference. As we save this, keep an eye on the command line And hopefully you find that if all goes well, the test suite should be fully green once more. Awesome. So that completes the Clear blockchain transactions functionality, along with a more generic clear method. That first clear method is actually the one that is going to be the final step in the mine transactions method. Clear blockchain transactions, on the other hand, is going to be what peers will call when they accept a new blockchain to be replaced, since it's a safer version of the clear method and it doesn't have the chance of wiping away unaccounted for transactions in the local pool. All right, as our next step, let's finally call all of these methods in the mine transactions method to tie the whole functionality together.